Hi, Mr. Novak here. Continue on with let's exercise 5A using the null factor law. So we're now stepping it up and looking at some other formats that quadratics can appear in. And a lot of the skills that we're going to use today I learned from the previous topic in term 1 on algebra. So the testing that we'll be doing in week 10 will be combining the two topics so nicely. So we can sort of see how you're progressing. So today I need you to open up the PowerPoint and go to slide number 13. So going down here, slide number 13, and we'll start our session there. Hopefully this will work. Yes, excellent. All right, so let's have a look at what we have in front of us. In actual fact, when looking for the x-intercepts in quadratics, we saw in the previous exercise we need it in factorized form. However, it usually comes, and when it does come in a factorized form, it's very easy to find the two x-intercepts if it has those two. And that's simply if its coefficient of the x term is 1, then it's just the opposite of b minus b. And if the coefficient is not equal to 1, in other words, like 2, then we go negative b over a. The next format, of course, is the trinomial ax squared plus bx plus c. Sometimes it only has two terms. That's the special case when we have the difference of perfect squares. And the last thing that we learned in the algebra topic was on completing the squares, and here's where it becomes very useful, as you'll see in lessons to come as well. And the final one, which we'll start on the next lesson, is one where we don't actually use any of these skills. We just go straight to a formula that works out the coordinates and of the x-intercepts by just using the coefficients of the trinomial. So let's have a look at a couple of those examples. I'll be asking you to pause. So let's start with questions you'll do will be exercise 5A, questions 4. So let's have a look at the first example, which is a trinomial. Here we will have a equal to 1. So it's the simplified where there's only b and c, but of course they can be used if there is a. And remember, to factorize, we need the factors of a, c, the two multiplied together, and those that add up to the coefficient of the middle term. So in this example, we have x squared minus 4x minus 12. A is 1, C is minus 12. 1 times minus 12 is negative 12. And the x term has negative 4, so that's what b is. And now we have to dice with our numbers. The challenge is to come up with the factors of negative 12 that add up to negative 4. Well, first of all, knowing that it's negative 12, one has to be positive and one has to be negative. And the fact that b, the middle term, is a negative value, we need more negatives than positive because we need these two to add up. And in this case, they add up to negative 11, which is not quite what we want. So the next factor we'll look at is, of course, 2 times negative 6. Remember, we need more negatives. So there it is. That's negative 12. And here's the beauty. Add those two numbers together and you get the negative 4. So there's our solution or our combination that we're looking. The factors of AC that add up to B. So we end up putting x minus 6 and x plus 2. And now we have it in factorized form, just like in the previous lesson, where using the shortcut, the opposite, when the coefficient of the x term is 1, it's just the opposite. There we have the opposite of plus is plus 6 and the opposite is minus 2. Don't forget we need to practice our set notation. So using, it's important, that's round curly brackets, that's 6 comma negative 2. So that's actually 2 points. Or as coordinates, remember we would use the round brackets and that's 6 comma 0. When y equals 0, x equals 6. When y equals 0, x equals negative 2. Let's continue on. The next type is where the trinomial actually isn't a trinomial, it only has two terms. And that occurs when we have the difference of perfect squares. It's really easy to factorize. Just square root the first term, square root the second term, 1 minus 1 plus. So here we go. The square root of x squared is x. The square root of 16 is 4. So it'll be x minus 4, x plus 4. It really is that simple. And to again, we have it in factorized form. So the solution is the opposite of -4 and +4, which is plus or minus 4. We can combine them. Set notation, uh, plus or minus 4, and the coordinates. Remember, round brackets, not curly. Occasionally they try and trick you. In other words, they give it to you as 5x squared equals minus 35x. Remember, it is a quadratic because I know it's an x squared term is the highest term. All I need to do is bring everything to one side so I have it as the null factor law. Then I go and factorize. The common factors of the number is 5. Common factors of the pronumerals is x. And we have 5x equal to 0. Or x plus 7 is equal to 0. So x must equal to 0 or minus 7. And we have the notation, curly brackets, and the coordinates, round brackets. So what I need to ask you to do now is pause this video, maybe take some notes, go to question 4 and do those exercises. You will find that on page 212. And you should have practiced that well. So I'll pause this now. So how'd you go with exercise 5A, part 2, sorry, question 4. We now move on to a couple of special situations where they say they want the exact value, and that's because we actually end up with surds. And we did a topic on surds right early in the term 1, so this is where it becomes useful skills that we have acquired. So let's look at the first example. We have a simple one, DOPS, again, remember square root of the first term, square root of the second term, and you have the x minus b, x plus b. So it's easy enough to square root that, simply x. But what's the square root of 5? And the answer is, oh, it's not really the difference of perfect square. We can set it up, can't we? There it is. Now can you see the square is a perfect square? And the square root of 5 squared is 5. So we haven't changed anything. And now we take the square root of x squared is x. The square root of 5 squared is square root of 5. So x minus root 5 and x plus root 5. And to again, with the unit coefficient for both the x terms, it's going to be x plus or minus root 5. In other words, the opposite. And your set notation, curly brackets and coordinates, round brackets. Do one more. Some would say 24 is not a square number, nor is 2. But that's why you always must remember, take out common factors first. Otherwise, we could take out negative 2. We're left with x squared minus 12. We can easily turn that into a surd. So in other words, square root of x squared is x. The square root of 12 is root 12. 1 plus 1 minus, because it is the difference of perfect squares. This 2, you'll find out, is just a dilation factor. Still important for you to leave it there, but where it cuts the x-axis will be at the opposite of those 2 because the coefficient of the x term is 1 plus or minus root 12. Set notation, you work it out, but just remember curly brackets and coordinates, make sure they're in round brackets. So now I ask you to go and do exercise 5A, question 11, A, C, G, L, and K. Yeah, look, pause this and come back when you finish those exercises and also having made some notes. All right, hopefully you had success with that. And don't forget, it was very easy when we used the solve on the calculator, which we did practice getting all those solutions. We're using it to test it. Now, I just want to jump to question 23 because they have the trinomials that are a little bit more complicated, where the a term or the coefficient of the x squared is not 1. And so that's the interesting challenge. So I'll do A, 23A, and I'll ask you to do the rest for this next section. So obviously we can't factorize because 2 is not able to be taken out. So we have the same process. The factors of AC, 2 times 15, that add up to B, 13. So in this case, AC is 2 times 15, which is 30, and B is 13. So can you think? This time it's a positive 30. So, and the B term is positive, so we're dealing with just positive numbers. So can you think of? Yes, 1 times 30 is a factor of 30, but unfortunately they add up to 31, and we wanted to add up to 13. What's the next factor we could try? Yes, 2 times 15 is also the factors of 30, but they add up to 17. Not quite. What's the next one? Can 3 go into 30? Yes. Yes. 10 times 3, and guess what? 10 plus 3 is 13. So there's our solution. In other words, remember, it's going to be x plus 10 and x plus 3, because we want both of them to be positive. So we're going to split the middle term. Sorry, we're going to split the middle term into 10x and 3x. Apologise, go back. We worked out the two numbers. We split the two terms, the 13x into 10x plus 3x. And now we factorise in pairs. Remember, that was from our previous topic. So we go factorising these two. We have a common factor of 2 and a common factor of x. We took out 2x, divide that by 2x, we're left with x, divide that by 2x, we're left with 5. Then looking at the last two terms, the common factor of 3x and 15 is 3. And now we have a common factor of those two expressions, 2x times x plus 5 plus 3 times x. So we take out the x plus 5, and we have 2x plus 3, the 2x plus 3 in one bracket, and x plus 5. Now we have it in factorized form, so we're able to very simply use our little trick. If x is not is equal to other than 1, it's the opposite of b over a. So that's going to be b minus b over a is minus 3 over plus 2. Or when x is a unit, 1, we just do the opposite. And so there's our x-intercepts for the 2. So have a go at question 23, B, C, D, E. Again, practicing work that we did earlier in term 1. I'm now going to stop this video. There'll be a second part for you to do the last section on completing the squares. So I'll be closing this and you'll be going to part 2 video.